Okay, so what we're going to look at today is the 2019 question B3. This is a question based on the Pilo Hotel in County Meath. It's comprised of a series of planar glass surfaces. With this question, the main part of the question is dihedral angle. Okay, now dihedral angle is the angle between two surfaces. So if I take this here, this is just a simple sticky note. Pretend this is a roof. The dihedral angle is the internal angle here between the two surfaces. Okay, so that's what we're trying to find for this hotel. So if you look at the graphic of the question, you'll see you're looking for the internal angle between the two glass panels. Okay, so the first thing we're asked to do is to draw the plan and elevation of the intersecting planes A and B. Okay, so in the question it's just given to us as a 70 by 70 grid, and the scale is 1:1. So it's going to be, there's 14 divisions on the grid. You don't need to draw all of them, so you can actually just count in the boxes for each of them, for each of the positions. So if you take one box as being 5 by 5, you'll get the position of each point on it. Okay, so I'll draw my box first to start with. Okay, so if we look at our graphic, we have one point here, we have 1.3 boxes up, and then the other one is 2 boxes up. So 3 boxes would be 15. 2 boxes up from that would be another 10. Okay, so the first one is going to join here to the corner. The next one joins the point here to find that first. Okay, I'm going to put my points up here first, so it's 15, another 10 from the 15. Now, I have to get my point here to connect it to those. So to get that, it's in 3, 4, and up 4. And it's at the center of that box. So it's, if I came in, what I might do is I might just draw that small grid there. So it's 20. And it's 5 by 5. Okay, now what I'm doing here is I'm getting the position of that point. If you look at the graphic, it shows us that the point is at the center of the square of that square in the grid. So we know that that square is 5 by 5, and to get the center of the square, if we join the diagonals, we get the center of it. Now, that's my plan view of the shape drawn. I'm not going to put in P and Q yet. I'm going to wait because I don't want to confuse you. Okay, so I'm going to leave that till a bit later. So my first point at the very top here, I'm 60 high, and this one over here is 40. Now, okay, so if we look at our graphic, the point that's on the ground is this point here that we bring up. Okay, so bring that up first. Okay, our next 2 points are our hidden detail. Okay, so our hidden detail is going to be of these two here. Okay, so the one that's going to be on the ground, if this point is on the ground, this line has to be on the ground. Okay, so if we bring that one up, now this one, this point here is obviously in the air, so this point is going to be in the air as well. We're told in the question that it's 40 high, so I'm going to bring across my 40 first. Just the construction line, and I'm going to bring that up then. Now, look in the question where the point is going to. So it's going from this point, which is here, to here. We found that there, and it's coming down to the ground. Okay, so if we do that in elevation, we get the correct detail. Okay, so that's part A of the question draw, my plan and elevation. Right, part B asks me to determine the dihedral angle between the planes A and B. Okay, so plane B is over here, and A is here, so this is B, and this is A. So the angle between them is going to be this line here. Okay, so we have to get the dihedral angle between that. Right, now I'm going to give the points on that line names, so I'm going to call this C and I'm going to call this D. Okay, to get a dihedral angle we need to take two auxiliaries. Okay, the first one is looking perpendicular to our line, and then the second one is looking at the line as a point. Okay, if you don't understand what I mean, you'll see what I mean now in minutes. Okay, so my first one, I'm going to look directly, I'm going to take my auxiliary looking directly perpendicular at line CD. Okay, so that's at 45 degrees, so I'm going to come off it 45 degrees to look at perpendicular. Okay, I'm going to draw my X1, Y1 up here. Now, if I look at it, these points are going to be on the same line, so I will need to bring up and set them. Okay, so I need my compass now. Now, if I was to look at that line CD on the elevation, so C is up in the air, and D is on the ground. Okay, so D is going to be here on the ground, and C is going to be up in there. So I'm going to get my height from my elevation. And it's got to be there. Okay, so that's where we will see this. Okay, my next point is I need to get this point here, which is here. So that's 40 high. So that's going to be on the outside one here. Okay. Now, this point here is the same as this one or this one, so it's going to be on the ground. Now, okay, so that's my first auxiliary taken. What I need to do now is I need to take a second auxiliary looking perpendicular at the line CD. So I'm going to look at this directly along here, so I'll see it as a point. So when I see it as a point, I'll be able to see directly into the angle. Okay, so like my piece of paper I had earlier. Okay, so the angle between the two is what I'm looking for. Okay, so that's why I need to see that as a point. Okay, I'm going to be caught a bit for space here, but I'm trying to make it work. Okay, now where I get my heights from this are from my x1, y1 back to my plan view. Okay, now that's a fair distance, so I might take a datum. Okay, so a datum I'm just going to draw right here, and I'm going to take my heights from here. Just saves me a bit of space when I'm doing the question. Okay, now, if I look at the distance between C and D here, that's the first point I'm going to get. It's the exact same. Okay, it's the exact same because we're going to be looking at it as, again, a point. Okay. So C and D are going to be in the one position. Now, we have two options here. We really only need the distance between like this line and this line, or this line and this line. Okay, we actually don't need to bring them all up. You'll see that if you do bring them all up, they'll actually be on the same line when you bring it out. Okay, so I'm going to pick the two external ones here. So this one here and this one here. I'll just continue with that line a bit further. Right, that's my dihedral angle found. Okay, so this angle in here is my dihedral angle. Okay, that's part B of the question answered. So part C of the question is asking me to project an auxiliary elevation of plane A on the x1, y1 line, hence determine the inclination of degrees, the inclination of plane A to the horizontal plane. Okay, so we're going to project that out, right? So again, to get the inclination, we're going to have to look at this perpendicular. Okay, so we're looking along here. So I'm just going to project out my points. I'm going to call that x3, y3 because this was x2, y2 over here. Okay, so again, to get the inclination, we're looking at it perpendicular, right? So to get that, we just need to get our heights from elevation. Now, I'm only going to get one height, and it's this 40 millimeter one here. So that's this point here. So if I draw this in. Now, I'm only going to get one height because when I draw this up as far as this line here, the second further line, it should give me a measurement of 60 millimeters. And that would prove that I have the correct auxiliary taking. Okay, so it's just that 60 there. Okay, now the inclination to the XY plane is what they asked for. So they're looking for this internal inclination here, so you need to get your protractor in on the line. So it's coming out at about 104 there. Okay, so 104 degrees. Okay. Now, the last part of my question is asking me, so laser lights are used to enhance the entrance of the hotel at night. The inclined straight line PQ represents the path of a laser beam. Determine the points of intersection of PQ with the planes A and B. Okay, so the first thing I need to do is obviously drawing my laser line. So P is 5, 10, 15, 20, 25, 30, 35. And Q, P, and Q joins it here in the corner. Okay, I'm going to colour that in blue. I need to find out an elevation now. Okay, so it tells me that Q is at 60, so we have that height already. I'm going to bring that across, and it's up here. So that's Q. And P is on the ground here. So P is here. Now, I'm just going to zoom in a small bit on that. Okay, so now with that done, what we're looking for is we need to bring where it crosses each of the planes up to elevation to find our points of intersection. Okay, so I'm going to start on this side here. So I'm going to do, this is 1 point. This is going to be on the ground, okay, because I know that the internal line is on the ground. This one here then is going to be up on the top, because I know that this line out here is the top line. Okay, so I now have 2 points, but I don't have a point of intersection. Right, they're just 2 points on the plane, and they're also giving me where the laser crosses it. Right, so if I bring those points up, or sorry, if I join those points, they give me the point that crosses the laser, or sorry, the laser crosses the plane. Okay, so I'm going to do the exact same thing on the other side. Right, so again, the outside line is the line on the top, so this is my top line here. And this line is going to be on the ground. So again, if I join those, that will give me my point of intersection. So they're my 2 points of intersection for the laser beams. Okay, so I'm just going to label those up here. Now, so that's my full question answer. Okay. Now, it's very easy to go away from that question and just leave it and say you have it done, but you'll want to revise this. So what I advise is to do a rationale for each section. So say exactly what you did in the steps for each section. Okay. So if we recap, you drew in your shape for part A. You should all definitely be able to do that. Your part B then was your dihedral angle. So you need 2 auxiliaries for that. So your first one is looking perpendicular at CD to get, you're getting the true length of CD there. Okay, we'll actually fill that in green to make it a bit easier to follow the steps. And it's going to be a point there, a green point. Okay. When we have that done, we need to look down along CD to get the dihedral angle. Okay, so that's how it's turning out of the point. Okay, and again, we only need to get the external ones or either the internal ones as well, which will be on a different line. Okay, you can prove that yourself if you want to go back and just see if they come out and they hit the line. This one here again, it's another auxiliary view, so we're looking perpendicular to the internal line here. We get an inclination of 104. We get our heights from elevation. Again, you only need one height, so I took the one here, which was 40. So if we call that H1, and this is H1 here. Okay, and then this one will actually give me 60. Okay, and then my third part, or sorry, my fourth part of the question was draw the line PQ. Where PQ crosses the 2 surfaces, we project up those points, we join them. So for example, we joined here and here, and where that crosses the line PQ will give us our point of intersection. Okay, so please write in a rationale for a question after you have it done, so that you know you've done it correctly.